Hello everyone, I am Samip, and in this video I'm going to be teaching you how you can create plots like this, also known as pass maps or pass networks in Python. So this is the one I created from the game Arsenal versus Manchester United from the Premier League 2015 season. So I'm going to be making a new one in this video, and I'll be showing you through all the steps you need to follow to make such kind of plots. So now to make such kind of plots, you need to have something called event data. So basically what event data is it contains each and every single action in a football match, like passes, tackle, any kind of defensive action, fouls. So basically every small action is contained in your event data. So the options we have is Statsbomb currently provides free event data from past competitions, which is publicly available. So we can work with Statsbomb data, and this is what we'll be using for now. So you can go to the website. You can also go to their Git repository. I'll have all the links in the description. So there's tons of matches from the past seasons, not the current season but the past seasons. So I'll just tell you what this data contains. So basically you'll have four things in this data. First is about competitions and seasons. So what kind of competitions are available, what their Statsbomb has covered in this free data will be available there. Then there will be data about matches for each competition, and then we'll have the event data and the lineups data. Now we'll be specifically working with the events data, but we will have to go through this competition and matches data in brief to get our match ID. Now there's also documentation. You can also go through this folders to see what's here. So basically you'll get this documentation PDFs. You can go and download it. So I have already downloaded, so I'll just tell you what you will find here. So here you'll basically find all kinds of as I said, there will be competition data, match data, lineup data, and event data. And so what this document PDF file contains is all kinds of attributes that are in the data and what values those attributes take and what each value means. Like you can see the lineup data contains player ID, player name, jersey name, player nickname, country. So likewise event data contains a lot of things, you know. So yeah, block, 50-50, dribble pass, disposal, everything. So we're not going to need all of this. I'll just go through the process and you'll know what kind of things we will need. So let's get started. So I'll be using Jupyter Notebook. You can follow along in any other IDE. So the libraries you will need is, first of all, you will need the Statsbomb py package. So if you do not have this, please install it before proceeding. Then we're going to need pandas. Then we will need something called MPL Soccer. So MPL Soccer is used to draw the football pitch and also to parse our Statsbomb data. And then we will require matplotlib as well. Now I'm going to go through the competitions data as I said in the beginning. So we're going to write sp.competitions, and I'm just going to print it out. As you can see, it contains the list of all the competitions that are covered in the free Statsbomb data. As you can see, there are so many columns here. If you go through the documentation, then you'll get to know what each of them means. Now let's just take a look at what competitions are covered. So I'll just go to the competition name column and see the unique values. So as you can see, there's Bundesliga, AFCON, Champions League, FIFA World Cup, Indian Super League, Premier League. So I'm just going to filter the ones from the World Cup. Competition name equals to, I'm just going to paste it. So yeah, so now it will show me the competitions from the FIFA World Cup, meaning it is going to show me which seasons are covered. So as you can see, 22, 18, 19, 90. So these seasons are covered. Now what I'm going to do is, for the 2022, you can see that the competition ID is 43 and we also have the season ID. Now using the competition ID and season ID, I'm going to access the matches data, and so I'll just get all the matches that belong to the 2022 World Cup. I'm just going to print it out. Now you can see what matches are available. So now I want to access the Argentina versus France final match. So I'm just going to filter out the data that has the home team as Argentina. So as you can see, there is the Argentina versus France final match. The scoreline was 3-3. Now what we need is, there is something called match ID here. So using this match ID, we can get the event data of that game. So we have to copy the match ID. Now I'm going to use the MPL Soccer library to get the event data in the parsed form. So I'm going to use the SPOpen object. And then I'm going to pass the match ID that we copied earlier. So now our data will be stored at df, and as you can see, this is the event data. So there are a lot of columns. You can go through the documentation to see what each of them means. So we're not going to need all of them. I'm just going to show you all the columns. So as you can see, there are a lot of columns: duration, player ID, player name, pass recipient, pass length, the X and Y coordinates. So these are all the columns in the event data. Now since we're going to only create the pass map of one team, so I'm just going to filter out the data for Argentina. So currently the data is for both Argentina and France. So I'm just going to filter out the data for Argentina using the team name column. So now this is the data only of the Argentine players. So now what we're going to do is, now we're going to need data only relating to passes, right? So I'm just going to see what kind of events are covered in the data first of all. So using the type name column, as you can see, so there are fouls, ball carries, recoveries. So yeah, what we need is the pass. So I'm just going to create a new data frame, passes, and I'm going to filter out the data containing the type name column as a pass. Now these are the passes data. So all the events relating to passes are in this data frame. Now what I'm going to do is, I'm just going to remove the columns that we are not going to need. So I'll just copy it from my previous code. So I'll have the links to the GitHub repository in the description, so you can copy it from there as well. So we're going to need the minute, the player ID, player name, the X and Y coordinates of the passer and the receiver. We also need to have the data of the recipient and also the outcome of the pass, right? So these columns are covered in this data. So now if I see the passes data frame, now this looks much more understandable. So as you can see, there is the player ID, there is the player name, and the X and Y coordinates of the passer, and then we have the NX and NY coordinates of the receiver, and we have the outcome ID and outcome name of the passes. Now we need to filter this data some more. What we need to do is, we need to filter the passes that are only successful passes. So let's just see what kind of outcomes are available here. So yeah, we have NAN, we have incomplete, offside, unknown, and out. So there's not something given as successful pass. So I'll just go to the documentation to see what kind of a pass is considered successful. So let's just search for pass outcome. So yeah, this is the event pass. So these are the attributes for the event. Now let's look for the attribute outcome. So yeah, there it is, outcome. So these are the values it takes, and so yeah, it's written that passes missing an outcome are completed passes. So what we can do is, those passes that are given NaN, so we can consider those passes as successful passes. So I'll just create a new data frame again, successful, and I'm going to filter the passes that did not have a value. Passes outcome name, I can use the is null property method. So now we have all the successful passes. Now we had 693 rows. It is reduced to 560 rows of data. So yeah, we have filtered the passes as well. Now what we do in pass maps is we take the data before the first substitution occurred, so that we can plot the pass map of the first 11 players. So I'm just going to go to the df data again and find out when the first substitution occurred. So I'm going to access the event substitution, and then I'm going to access the minute of that substitution, and then I'm going to find out the minimum value from those substitutions to find out the first sub. I'm just going to print it out. So as you can see, the first substitution happened in the 63rd minute. So what I'm going to do is I'm going to filter my data successful passes to only take those data that occurred before the 63rd minute. So I'm just going to refilter it by passing the minute column as before the first sub. And now we have the data before the first sub. We had 560 rows. Now it is reduced to 317 rows. Now one problem we have here is we only have the player ID and the player name. In pass maps, we generally put the jersey number in the player notes. So what we're going to do is we're going to bring the jersey number from the lineups data. So I'm just going to go through the lineups data using the match ID that we copied earlier. So I'm just going to copy the match ID again, and I'm going to pass it to the parser to get the lineup data, and I'll just filter the columns out. We only need the player ID and the jersey number. So I'm just going to filter it. It's a small mistake there. So I'll just print it out to show you. So yeah, we have the jersey number for each player ID. So what you're going to do is I'm going to merge this data frame with our successful passes data, so that we'll instead of player ID we'll also have the jersey number there. So I'm just going to merge these two data frames, and since we already have a common column in the name player ID in both the successful data frame and in the jersey data frame, so I can merge those two data frames using the column player ID. So I'm going to use pd.merge. On player ID, and now what I'm going to do is, once the data is merged, I'm going to rename the column jersey number as passer, so that because we'll be working with that number specifically, so I'm just going to rename the jersey number as passer. So I'm going to rename this column as passer. Okay. So I'm just going to set the in place equals true, so that the changes take place in the original data frame. So now let's see the successful data frame. So as you can see in the last column, we have passer data. So we have the jersey number of all those players. Now we're going to have to do the same for the pass recipients. So instead of player ID, here we have the pass recipient ID. So it is the player ID, but with a different name. So I'm just going to copy this code. And now we have to add one line here because the name is pass recipient ID instead of player ID. So what I'm going to do is I'm going to rename the player ID column in the jersey data frame as pass recipient ID, and I'm going to merge those two data frames. Okay. So I'm just going to rename it as pass recipient ID. So I'll add the line here. Jersey data dot rename. Now if I run this, so looks like there is a mistake. Oh sorry, I just misspelled the columns. So now if I look at the data, you will see that like the passer column, we have a recipient column now, and it contains the jersey number of the player that received the pass. So in pass maps, what we do is we plot the average position of the players. So we need to calculate the average x and y coordinates of every player. So what I'm going to do is I'm going to group the successful data frame by each passer, and using the aggregate function, I will calculate the mean for both x and the y coordinates. We'll calculate the mean and also the count. So the count will give the number of passes given by a player. So I'm just going to add it to its columns. So we now have the average location for each passer along with the number of passes the player was involved in. So now what we're going to do is we need to calculate the number of passes between all possible combination of players. So I'm going to create a new data frame, pass between, and I'm going to group the successful data frame once again by the passer and the recipient. And I'll calculate the count and put it in the ID. I'll just rename the ID as pass count since we have put the count value. So now let's take a look. So yeah, we have the pass between data frame ready. So we have the passer, the recipient, and pass count for each of the combinations. So now what we need to do is we need to merge the pass between data frame and the average locations data frame so that we can have the average locations of the passer, average location of the recipient, and their pass count in the same data frame. So we're going to merge these two. So I'm going to overwrite the pass between and I'm going to use pd.merge. Pass between and average locations with the common column being the passer. Now if I take a look, so you can see that we have the x and y coordinates, average locations, and the count value for the passer. Now we need to do the same for the recipient. So I'll just copy this code and paste it. Now we need to do it over the recipient column. Now before that, what I need to do is I also need to rename the column of average locations as passer or as recipient, because it is passer right now. So if I rename it as recipient, then I can merge the two data frames. So I'll just use rename access because it's in the index. And so since I will merge it, the names cannot be same, so I'll just add suffixes so that it will appear as X end and Y end. So let's take a look. So yeah, we have the average locations of both the passer and the recipients as X end, Y end, and count end. So our data frame is ready. So now we can proceed towards drawing the pitch and plotting our pass maps. So we actually forgot one thing. So in the pass maps, we don't want every single pass to appear. So generally we'll set some threshold. So I'll just filter out the passes that are only greater than 3 in number. So if that pass has been played more than 3 times, then only we'll consider it to put it in the plot. So I'll just filter it out. So now the it's not working for some reason. So, oh yeah, it should be pass count actually. Now it should work. So yeah, as you can see, some of the passes have been removed from the data frame. So yeah, now we are ready and we're going to draw the pitch. Now to draw the pitch, I'm going to use the pitch object from the MPL Soccer library. So I'm going to give the pitch color as white, the line color of the pitch something darker, it's like something gray. So actually you can find this documentation MPL Soccer. I'll have the link in the description. So you can find all the information about how you can draw the pitch, what kind of customizations you can make, and what kind of properties this kind of pitch has. So you can go to this link and see the documentation to customize it as per your requirement. So you can also go to the example sections to see example plots for each kind of purpose. So for now, I'll just create a simple one. Now I'll give the figure size. And now I'm going to draw the pass lines. So to draw the pass lines, I'll use the pitch.lines method, and now I need to pass the X and Y coordinates of the passes. So I'm going to use the pass between data frame and give the X and Y values. So one thing we need to keep in mind here is the pitches in MPL Soccer are scaled by the factor 1.2 in the X direction and 0.8 in the Y direction. So every time you use these coordinates, you have to multiply by these factors. And similarly, I'm going to add the end value of the coordinates. Then I'm going to give the line width. So the line width will be according to the pass count. So the more passes that are played, it will appear more wider. So I'll just give the pass count value and multiply it by 0.5. I'm going to give the color as red. So that is it for the pass lines. Now we need to draw the notes, so the player notes. So for that, I'm going to use pitch.scatter. and we need to pass the average locations of the players. So I'm going to multiply by the scaling factor and give the x and y coordinates once again. So the size will give the size of the player nodes according to their involvement, so according to the number of passes they have played. So I'll multiply the size by the count variable in the average locations data frame. So the more number of passes a player has played, it will appear bigger in the pass map. So I'm going to give the color as white, and then I'll give edge color as something darker. Now what we need to do is in the nodes we have to put the player jersey numbers. So for that I'll loop through the average locations data frame. So in the average locations data frame we had the index as the passer, and we had the jersey numbers there, player numbers there. So we will loop through that data frame, and I will use that index to plot in this plot inside the nodes. So I'll use pitch.annotate, and so the index is what we are needing right now. So I'll pass the index and I'll give the xy coordinates. So remember, you need to multiply by the scaling factor. So a row here refers to the value, x and y refers to the value in the data frame. So I'm using a row from the for loop, and then I'll pass the color in the C, and I'll make the font bold, and VA stands for vertical align. I'll align it in the center, similar for horizontal align too, and I'll give the size. Then so we have drawn the pass lines, nodes, and the player numbers. So let's see how the figure looks. So it looks like there is a mistake. Oh yeah, I've just mistyped it. So let me just correct, and now let's see the plot. So yeah, there's a small problem there. So we need to make the nodes appear further forward than the red lines. So I'll just add the z order value in the pass lines. So now it should be fine. Yeah, so yeah, we have our basic plot ready. So you can see that everything is working. The nodes are sized according to their involvement, and the lines are thicker where there are more passes. So let's just add a few more things. So I'm going to add the plot title, so to show which game the plot was about. It's going to give the colors and the alignment. So yeah, it looks better. Now I'm just going to add a few more information. The World Cup final. Since it's the annotated method, we need to pass in the coordinates. Just copy it from my old code to make it quicker. So similarly, I'll add something at the bottom right. It could be your Twitter handle or anything like that. So I'm going to use the text method here, and I'll just add my Twitter handle, and then I'm going to give it the color and the alignment. So now if I run this, so yeah, our plot is ready. So you can, as you can see, there's my handle and there's the title, there's the subtitle. Now if I look the image in the another tab, so yeah, as you can see, everything is perfect. So the nodes are sized according to the number of passes they have played, the average locations are plotted, and the plus lines are also according to it. So if you want to customize anything in the pitch, you can go to the MPL Soccer documentation, and you can choose what you want to customize. So yeah, this is our basic pass plot. So this is how we create pass networks in Python. If you have any questions, you can drop them in the comment section. Also, if this video worked for you and you like this tutorial, please like this video and please subscribe to my channel. Thank you.